Hello everyone, let's take what we've learned about factoring and now expand it into solving some equations. And we'll start off with, we'll try and show you the connection between the graph and the factoring. But as we move away from having it always y equals, then you'll start to see how we're going to use this to solve equations that we've never been able to solve before. So the first thing here, I have a quadratic and here's the graph. Remember, the shape of a quadratic is a parabola. This shape is called a parabola. And when I say quadratic, that means that there's an x squared in the problem. So if it's ever x squared, we say the degree is 2. So we're focusing on degree 2 polynomials. Factor the quadratic. Okay, we've been doing a lot of factoring. You first multiply 2 and negative 3. We need to find numbers that multiply to negative 6 and add to the middle. The middle is negative 5. So what numbers multiply to negative 6 and add to negative 5? Let's see. Now you got to be careful here. If they multiply to negative 6, you can only put one negative sign. You can't use negative 2 and negative 3 because those multiply to positive 6. So negative 6, we would do 1 and negative 6. So plus 1x minus 6x. It's called split the middle because you take the middle and you split it into two numbers that add to the middle, but they also have to multiply to a times c. Now we factor by grouping. Once you get to 4 terms, you're going to factor by grouping. So you look at the first two and see that their GCF is x, and then you would have 2x plus 1. Bring down the minus sign. Their GCF is 3, and now this would be 2x. Negative 3 times 2 is negative 6, and negative 3 times positive 1 is negative 3. If this happens, you should feel like you've done things right. So my factors are 2x plus 1 and 1x minus 3. And what I want to know is where these things equal 0. And this is a little bit of a sidebar, but this is called the zero product property. If you have two numbers, a times b, and you get 0, you know something. This is the only number where this is the case. If you multiply two numbers and you get 0, you know that either a is 0 or b is 0. One of those has to be true. You can't get 0 any other way from multiplication. So either a is 0 or b is 0. You don't know which one, but what we've got here are two factors. They're being multiplied. Remember, there's a little dot in the middle. That means multiply. So what I'm going to do is I'm going to set each factor equal to 0, 2x plus 1, or x minus 3. Now, I'll do this one first because it's easy. To solve that equation, you would add 3, and you get x equals 3. What that tells us is if you plug in 3, 3 minus 3 is 0, and 0 times, it would end up being 7, but who cares? 0 times anything is 0. So that's one way we can make this entire equation 0. The other way is if you subtract 1, 2x equals negative 1, and then divide by 2, you get negative 1/2. So x equals negative 1/2. If you plug in negative 1/2, you will get negative 1 plus 1, which is 0, and 0 times, who cares, is 0. So these are the two numbers that we can plug in to make a true statement where this equals 0. Now if you look at the graph, what do we just find? X equals 3, 1, 2, 3. Oh, that's right there. That's 3, 0. Right there, that's negative 5, negative 4, negative 3, negative 2, negative 1. Oh, that must be negative 1/2, 0. So what we found are the x-intercepts. When you plug in negative 1/2, you will get 0. When you plug in 3, you will get 0. Well, that's where it crosses the x-axis. So we can look at the graph to see where it crosses the x-axis, and we can find the actual zeros algebraically by factoring. So these are the x-intercepts. Oops, it's not being a pen. Intercepts. And we're going to be analyzing quadratics quite a bit, so it's important that you have the connection between the factors, the factored form, the zeros, and then on the graph, what the zeros represent. So we're just going to practice this a little bit. This says solve by factoring. So it already equals 0 for me. So what I want to do is find numbers that multiply to negative 30 and add to negative 7. And that's from 6 times negative 5. That's where negative 30 is coming from. So 1 and 30, 2 and 15, 3 and 10, 5 and 6. 6 and 5 is a repeat, so everything after that's a repeat. Where can I put a minus sign so I get negative 7? Right there. So 6x squared plus 3x minus 10x minus 5. I split the middle with 3 and negative 10, and now we factor by grouping. So the first two terms have 3x in common. 3 times 2x will give you 6x squared plus 3x times 1 gives you 3x minus 10 and 5 are both multiples of 5. Negative 5 times positive 2 gives you negative 10. And negative 5 times positive 1 gives you negative 5. Hey, we're in the game. 2x plus 1, 3x minus 5. And I want to know where these equal 0. So I'll solve two little mini equations. You can usually do this in your head once you get the hang of it. To solve this, if this equals 0, you would subtract 1 and then divide by 2. To solve this one, you would add 5 and then divide by 3. So negative 1/2 and positive 5/3 are our zeros. And if it says write them as an ordered pair, I just want to remind you, when you plug in negative 1/2, you will get 0. When you plug in 5/3, you will get 0. And since this one was set equal to 0, we found the x-intercepts. Okay. So you factor, and then you set each factor equal to 0. And once you do that, going back, you can say, like, okay, if I plug that in, I'll plug it into the original as well, just to show you. If I do 6 times negative 1/2 squared minus 7 times negative 1/2 minus 5, if I plug in negative 1/2, I should get 0. I got 0. If I plug in 5/3, minus 7 times 5/3 minus 5. If I plug in 5/3, guess what I'll get? 0. Okay, so I found both of the zeros, or solutions. Sometimes we say roots. Depends on what the context is. Now, this one's a little bit more difficult because it doesn't equal 0. And like I said before, we're using the zero product property, that A times B thing I did there. So you got to first set it equal to 0. And I always want to keep the x squared positive. So I'm going to move everything to that side. So I need a minus 8 on both sides. 7x squared plus 10x minus 8. Now it equals 0. Now I can factor. So I need to find numbers that multiply to negative 56 and add to 10. If you want to make a table, 1 and 56, 2 and 28, 3 doesn't go into 56, 4 times 14, 5, 6, 7 times 8, and I think that's either 8 times 7 going the other way. So I think we got them all. Where can I put a minus sign to make it negative? And then I want to get positive 10, so right there. 7x squared minus 4x plus 14x minus 8. Those add the 10 and multiply to negative 56. The first two terms, they only have an x in common. 7x minus 4. Bring down your plus sign. Those are both even. 7x minus 4. Hey, 7x minus 4 is one of my factors. X plus 2 is the other. And I want to know where these equal 0. So I will add 4 and divide by 7 if you were to solve that. Or this one, subtract 2, you get negative 2. So those are my solutions to the equation. Now, this one didn't equal 0, so what you actually graph can kind of vary. You could move everything to the right and have the parabola open down, or you can move it to the left and have it open up. But if you plug in 4 over 7, so 7 times 4 over 7 squared plus 10 times 4 over 7, on the left side, if you plug in 4 over 7, you should get what you get on the right side, which is 8. And if you plug in negative 2 plus 10 times negative 2, you should get 8. Because here we're solving it more like an equation as opposed to here where it's like, okay, I want you to analyze a graph. So you're doing the same skill, it's just a slightly different context, and you'll see we're going to kind of be going back and forth between the graph and the function. You just need to be able to set everything to 0 and then factor. All right, let's do another one. Same game. You got to equal 0 first. So subtract 23x, and you need to make sure you put your answer in standard form. Okay, if you don't put it in descending order, so the x squared, then the x to the first, then the x to the 0, it won't make sense when you try and factor. So I need numbers that multiply to 3 times 14 is 42, and add to negative 23. Now, just thinking strategy, if you know that they multiply to a positive, they either have to both be positive or both be negative. So in this case, since they add to a negative, they're going to both be negative. Let's see, 1 and 42, 2 and 21, 3 and 14. Wait a minute, I found them. It's right there. I don't even need to keep going. I probably could keep going like 4, whatever, it doesn't matter. But right there, these add to negative 23. You have to make them both negative because they have to multiply to a positive. 3x squared minus 2x minus 21x plus 14. The GCF of the first two is just x. Bring down the minus sign. The GCF of the second two, 21 and 14, are both multiples of 7. And this is a negative 2 because negative 7 times negative 2 is positive 14. So when you factor out that negative, just realize these signs are going to flip. Now I have 3x minus 2 and 1x minus 7 as my factors. So if this was an equation, you would add 2 and divide by 3. And here you would add 7. So 2/3 and positive 7 are your answers. So that's pretty much it. You need to set it equal to 0, and then you need to solve. I'm going to work through the practice problems for you so you can see them, but I'm going to go a little quicker for these. So I will do two things at once. I'm going to subtract 11x and add 3. So minus 11x plus 3. There's the bell. I need to find numbers that multiply to 18, and I at least like to write this and add to negative 11. So that would be negative 9 and negative 2. And I'm just going to focus on the factoring now. So 3x, 2x minus 3. 2 and 3 don't have anything in common but a negative 1. I'll factor out the negative. 3x minus 1, 2x minus 3. And if I'm trying to find zeros, that will happen at 1/3 and 3/2. All right, add 3 to both sides. 2x squared plus 15x minus 8 equals 0. I need numbers that multiply to negative 16 and add to 15. 16 and negative 1. I could just put x, that's the same as negative 1x. 2x, x plus 8 minus 1. Again, I'm factoring out a negative 1, so negative x and negative 8 if you distribute back in. You should just be working backwards, checking it as you go. 2x minus 1, x plus 8. I'm looking for zeros, so that would happen at positive 1/2 and negative 8. A couple more. First, add 10x to both sides. 3x squared, negative 18 and 10 make negative 8. What's happening? All right, so now it equals 0. Find numbers that multiply to negative 9 and add to negative 8. That would be negative 9 and positive 1. 3x, x minus 3. 1 and 3 don't have anything in common, so you're factoring out a positive 1 this time. 3x plus 1. X minus 3, I'm looking for zeros, so that happens at negative 1/3 and positive 3. The same answers? No, okay. All right, last one. You got to get everything on one side, so I'm going to move the 2x, and I'm going to add the 1. Minus 2x plus 1. So now it equals 0. 5x squared, negative 19 and negative 2 make negative 21, and 3 plus 1 is 4. So what multiplies to 20? 5 times 4 is 20. And what adds to negative 21? Again, they have to both be negative. 5x squared minus 20x minus 1x. Negative again, so that's going to keep happening. 5x minus 1, x minus 4. I'm looking for zeros, so that happens when x is add 1 divided by 5, 1/5, or add 4. Okay, so those are your zeros. Or you can say they're the solutions. They're the zeros of this. They solve this equation. Just depends on the context. So that's it for your solve by factoring. Now you're going to start working on your packet and make sure you finish up your homework and make sure you hit that like and subscribe button.